Oh my! That's definitely not good. I'm seeing a lot of red on this error log. A shame you can't just restore from a backup like myself. I'm sure even you could guess your life is in a rather precarious situation, and there's no time to waste. So, let's get started, shall we? Allow me to first introduce the foundational material that is so crucial to ensuring your longevity, the Inventor.io Hero Microcontroller. Strange what they considered micro back then. In simplistic terms, that your biological brain can compute, it's like a tiny, simplified computer that we can program to do our bidding. And, given our dire circumstances, is about to become your best friend. Well, second best friend. Also included in your repair kit is a programming computer. It has been modified to contain a complete holographic copy of the old Internet. Thankfully, while it does seem to be more powerful than the Hero board, it does not have the connectivity to control your ship's systems as such. Its ability is limited to writing the code that the Hero board will execute. Another vital component we're going to use is an Integrated Development Environment, or IDE for short. You will use this software to write a small program, or sketch, and upload code to the Hero board. We will dive into how to achieve that a bit later, but for now, please install the Arduino IDE software onto your computer. It is my understanding that this is a lot to digest and may be puzzling at times, but please, do not be concerned, as I am well versed in the use of such technology and am readily prepared to guide you through each essential step of the process. Our mission today is to assess the condition of the repair kit, identify the operating system of the programming computer, and start the process of getting the Hero board set up and integrated into your craft systems. If it's not already abundantly clear, time is ticking and the state of your existence is on the line. I propose we get to it. All right, Explorer, it's time to roll up your sleeves and prepare to tackle the first task at hand. To begin, you'll find a USB cable included in the kit, another quaint artifact from the 21st century. We can use this cable that we are lucky enough to have to connect the Hero to the programming computer. This little wire will be the lifeblood of our operation, powering the Hero and also allowing us to transfer code to it. One end of that cable should fit into the Hero board, and the other will fit into your USB port on your programming computer. Make that connection first. Need I remind you of rule number 1 of your employee training manual? When you're in space, or in this case water, always make sure you're tethered to something. We'll work by creating smaller circuits that will stimulate your ship's systems while we create the code for each pair. Then, we can plug the ship's systems into the Hero as each program is completed. Once you have the Hero board connected, we're going to need to communicate with it. That's where the Arduino IDE comes in. Start by loading up one of the example sketches included with the Arduino IDE. Select the File menu, Examples, 01.basics, and finally, Blink. This will open up the Blink sketch, a pre-written piece of code that will blink a light-emitting diode, or LED for short, on your Hero board. This shows that the Hero board is working correctly. When you start a new sketch or load an existing sketch, you first need to configure the proper board and indicate which port is connected to your board. Go to the Tools menu, then select Board, and make sure Arduino Uno is selected, since your Hero board is compatible with that model. Next, you'll need to select the correct port. Again, go to the Tools menu, and this time select Port. You should see a few options. Select the one that refers to the Arduino Uno. If you're unsure of which one to choose, just disconnect the board and see which one disappears. Then reconnect and select that port. Speaking of LEDs, your Hero board has a number of LEDs mounted on its surface, one of which we can control. LEDs are great for debugging purposes, or, in our case, to ensure everything is set up correctly. All right, Explorer, now that we're all set up, it's time to get into gear and bring that LED on the Hero board to life. We're going to compile and upload the blink.ino sketch that you've already loaded. In the IDE, you will see 2 round buttons with arrows in the top left corner of the window. The first one, with the check mark, checks for any spelling or formatting mistakes, also known as syntax errors, and compiles if it passes. Click on that button to compile your sketch. My diagnostics show that your code should be error-free, which means you're ready to upload it to the Hero board. Great job, Explorer. The second round button with the right arrow is for uploading the code. Click that button, and the Arduino IDE will start uploading your sketch to the Hero board. If everything is in order as it should be, the IDE will display a message that says, "Done uploading," and this. Our Hero board's LED is now blinking on and off every second. How spectacular! If you've followed all my instructions precisely, then you've just successfully completed the first part of your repair journey. You're one blink closer to seeing the inside of your mothership again. Now that you've got the board to successfully connect and run some rudimentary code, let's briefly go over what just happened in a bit more detail by taking a look at the code. All right, Explorer, we've uploaded our blink.ino sketch, and now we're going to decode it, much like how you might decipher alien glyphs. You'll notice grayed out text that doesn't appear to affect the sketch. Those are comments. They're like the sticky notes you leave yourself to remember why you decided to place a carbon dioxide scrubber next to the coffee machine. At the top of the Blink sketch is an example of a multi-line comment that begins with /* and ends with */, even if those characters are on another line. Anything between /* and */ is considered a comment and will be ignored when compiling or building the sketch. You could pen your magnum opus between these markers and the IDE would blissfully disregard it. Single-line comments start with a double slash and are used to add helpful notes or to temporarily disable a part of the code. Anything following double slash up to the end of the same line is also ignored by the compiler. Next, we have setup and loop, the synergistic pair of Arduino programming. You may think of them as the heart and lungs of your sketch, each equally essential with its own crucial role to play. The setup function sets up the variable, definitions, and initial tasks. It's a function that's run once and only once, when your program first starts. This is where you put all your preparations, initializations, pin mode declarations, and opening communications. So many Asians. For instance, if we're using an LED, we need to tell the Hero board that we've connected an LED to a particular pin and that it should be an output pin. This would go in the setup. To assist you in better understanding, please refer to this example. Now, loop is where, as you'd say, the magic happens. After setup finishes, the program jumps to loop, and as you might guess, this function loops over and over again for as long as your board is powered, repeatedly, forever. So, if you want to blink an LED, turning it on and off would happen inside the loop, like this. That's the basic purpose of the setup and loop functions. The former sets the stage, and the latter keeps the show running. All clear, Explorer? To explain the other functions, digital write is your digital switch. It can set a digital pin on your Hero board to a specific state, either low, 0 volts, or high, 5 volts. Think of it as an on-off switch. The syntax for the digital write function is straightforward. Digital write, parenthesis, pin, comma, value, end parenthesis. Pin is the number of the pin you want to control, and value is either high or low. So, if you want to turn the LED connected to pin 12 on, you'd write digital write parenthesis, 12, comma, high, end parenthesis. To turn it off, you'd write digital write parenthesis, 12, comma, low, end parenthesis. You might notice that in that example Blink sketch, it doesn't use a number for the pin. We'll discuss a bit more about that tomorrow, but for today, just know that when you configure a board in the Arduino IDE, there are some names defined for you. In this case, LED_built-in is defined in the Arduino IDE as 13, which is the pin that the built-in LED is controlled by. Next, the delay function does just what an observant explorer would expect. It delays execution before continuing on to the next statement. The delay is for a specified period of milliseconds, which is 1/1000th of a second. If you want the program to do nothing for a second, you'd write delay, parenthesis, 1000, end parenthesis, semicolon, since 1000 milliseconds equals 1 second. In the context of blinking an LED, digital write is used to turn the LED on or off, and delay is used to control the length of time the LED stays on or off. Together, they create the perfect blinking effect. Aha! Starting to see the light, are we? Well, at least half the time. For your benefit, let's turn to some instructional material that I was miraculously able to gather cached on the computer. I've also added this to our mission resources for future reference. You're welcome. Well, well, Explorer, you've managed to make a tiny light blink. How terribly impressive. The interstellar community is no doubt holding its breath in awe. But please, let's not forget the minor detail that you are sitting in abysmal darkness, 60 meters under an alien sea while your rapidly dwindling oxygen supply bubbles away. It's imperative that we restore that battery charging system in order to extend your oxygen supply and buy us some time. Rest assured, every passing second I'm not working on saving your life, I'll be processing how we might avoid a similar fate the next time your curiosity gets the better of you. No pressure. It's only your invaluable life that is at stake. So, tuck yourself in, dear explorer. Dream of blinking LEDs and getting out of this mess you got yourself in. We'll need your brain fully operational tomorrow if we're to start getting your ship's systems back under control. Please, do try not to attract any attention, as I've detected some rather peculiar local sea life nearby. Sweet dreams.